Today we're going to be talking about the law of sines. This is something that we use to find side lengths in triangles that don't have a 90-degree angle. So these are going to be in these acute or these obtuse triangles. And so this law of sines allows us to find those side lengths in certain angle values when we don't have our typical right triangle trig. And so this law of sines, you may have seen this last year. This is it's all based off of proportions, and we're going to look at where this comes from. We're going to look at an example, but when we do use this, we don't usually use all three. Actually, we never use all three. We just focus on which two angles or sides I care about. So I would either look at like side of A, or sine of A over side A equals sine of B over side B. Or I would go and I would look at like the last two, sine of B over B equals sine of C over C. Or if I had information about A's and information about C's, I would look at that. Remember, capital letters refer to angle values. Lowercase letters refer to side lengths, and they always pair opposite each other. So side A is always opposite angle A. Side B opposite angle B. So we're going to look at where this comes from, and this is coming from our normal right triangle trig. So we're just going to look at an example that deals with sine of A and sine of C. And the same thing would apply if I wanted to get sine of B in there, just a slight little tweak in how we draw it. So what we're going to do is we're going to drop in an altitude. Actually, before we do that, we're going to do the second step. We're going to label all of our side lengths. So remember, side lengths always match up opposite the angle value. So opposite angle A, that's going to be side A. And it's a lowercase because we're talking about a side length. Opposite angle B is side B. And then opposite angle C is side C. And so we're going to go back to that first one. It says, okay, we're going to drop in an altitude. Altitude is just going to say it's the height of our triangle. And when we draw in an altitude or we draw in the height, it's always perpendicular. So I just created two right triangles. We took this non-right triangle, we made it into two smaller right triangles. We're going to say that this height here is h. That's my altitude. And so looking at the two smaller right triangles, we're going to figure out what sine of A and sine of C are. And we're going to set up some equation between the two of them. So remember, sine, using our SOHCAHTOA friend, is opposite over hypotenuse. So sine of A is going to be in that right triangle on the left-hand side, opposite h over hypotenuse of C. If I look at the one on the right-hand side, sine of C is its opposite, which is also h, over the hypotenuse A, because we're looking at the two different right triangles here. If I want to somehow equate sine of A and sine of C, I want to get them solved for the same variable, so I want to get h alone in both those equations, in both the red and the purple. So if I do that, this right here gives me h is equal to C times sine of A. The purple equation there tells me h is equal to A times sine of C. And if these are both equal to h, then they have to be equal to each other. So together, I now get that C sine of A is equal to A sine of C, and then just doing a little bit of uncross multiplying or division, I get, and I'm sorry that this is a little crazy, I'm working backwards here, I now get sine of angle A over side A equals sine of angle C over side C, which is one of the pieces of my law of sines. So law of sines, it comes from taking a non-right triangle and creating right triangles out of it. You don't have to do this process every single time. We just get to we get the benefit of just using the law of sines. And so law of sines is going to be used when we have these non-right triangles and we're asked to find missing angles and missing sides. And so we're going to introduce this new term, this new direction. of solving a triangle. So solving a triangle just means to find all missing information, all missing sides, all missing angles. And so there's a couple different types of triangles that we can have, or a couple different types of pairs of information that we can have. But to solve a triangle, you do need to know at least 3 pieces of information. And one of those pieces needs to be a side. I can't solve a triangle if all I know is angle. All I know are angles. So there's 4 different types. You can have 2 angles and a side length. That's our first type. You can have 2 sides and then one of the opposite angles. You could have all 3 sides, or you could have 2 sides and the angle in the middle. This third and fourth type, those are going to be ones we're going to deal with later. Those are going to need to use the law of cosines, but 1 and 2, we can solve those using law of sines. So let's do one. I want to solve this triangle with this piece of information, but I want to start by drawing a picture, and I want it to be fairly accurate. Sorry, there we go. We're back. I want it to be fairly accurate. This does not mean take out your protractor, take out your ruler. I'm definitely not going to take out a ruler and measure a side length that's 28 feet. But I want it to make sense. Angle C is 102, angle B is 29. Angle C should definitely be larger. So I want to draw a triangle where my angle C is obtuse angle. And angle B is kind of small. So here's C, here's B, and then I don't know what A is yet. We can figure that out. But I want to label it, and when I want to go through and I want to label the sides as well. So opposite angle A is side A. Opposite B is side B. Opposite C is side C. And I want to label it first with the variables. And then I want to go through and fill in what I know. So angle C is 102. Angle B is 29. And side B is 28. Because I need to go through and I need to find all the missing pieces. And so this helps me keep a better idea of what I need to find. And so what I want to do is I want to create a list of what I need to find. I need to figure out what angle A is, what side A is, and what side C is. So if you know 2 angles on one side, it is almost always easiest to find the missing angle first. We're going to use a fact called the triangle sum theorem that just says all angles in triangles must add to 180. That is a theorem. It is always true. If we've got these triangles here, all the angles have to add up to 180. So that's going to help me find angle A. Easiest. So we're going to start with that. To find the measure of angle A, I know that if I take angle A and I add to it the 102 and the 29, all 3 of those add up to 180. So I just want to subtract 102 and 29. I want to take both of those away from 180. And you should get, didn't do this beforehand, so I want to make sure I get the numbers right, 49 degrees. So angle A is 49 degrees. And once I find that, I can go put that in my list. And I'm a third of the way done. We got 1, we got 2 more to go. So sometimes it's going to be a lot easier to find your angle. Other times it's going to be a little bit more difficult. We'll talk about those later. But we found our angle. Now I want to find a side length. And this is where the law of sines is going to come into play. I have a pair of opposites, 28 and the 29. Those are both my B's. I got angle B and side B, and they are opposite each other. And that is really important. That's the key thing in using law of sines, is that you have a pair of opposites. Because when I set up law of sines says sine of angle A or sine of angle B over its matching side, its opposite side, is going to be equal to sine of another angle over that angle's opposite side. So it's really important that I have a full pair. So I have that here. I know what sine of B is, or excuse me, I know what angle B is, and I know what side B is, so I can fill those in. I can say sine of 29 over just 28. Well, that's going to equal sine of my newly figured out 49 degrees for angle A over side A. I have one single variable, so now I just need to solve for A. And while I just said it, now I just need to solve for A. That's not always easy. Okay, we have one fraction equal to another, so we have a proportion. Whenever you have a proportion, you want to cross multiply. I want to multiply across my equal sign there, so I get, I get a beautiful A times sine 29 equals 28 times sine 49. And I want to solve for A, so I have one last step to do. To get A alone, it's currently A times something, so to undo multiplication, we use division. So A is equal to 28 times sine 49 divided by sine 29. And this goes straight into your calculator. Nothing here cancels. The signs do not cancel. So in your calculator, you want to type in that whole 28 times sine 49 divided by sine 29, and you get back 43.59. We'll round to 2 decimal places. And I can put that in my list. Okay. So to find the missing side lengths in these triangles, we will use law of sines. All we have left is side C. And if it was a right triangle, there would be more options, but this is a non-right triangle. I cannot just do some things I've done in the past. I have to go back to law of sines again. And I want to go back to that initial pairing we had of sine B. So sine 29 over 28. But this time I want to solve for C, side length C. So I'm going to do sine 102 over C. And again, I want to cross multiply and I want to get C alone. And when I do all of that, you should get C equals 28 times sine 102 over sine 29. And if you put that in your calculator as you see it, you get 56.49. Now, if you are not getting these numbers and you are typing these into your calculator, most likely you are in the wrong mode. So make sure that if we're doing these in angle values, which most of the time in triangles that are not related to those unit circle, those quadrants, these are just triangles out in the wild, they are going to be in degrees. But just make sure that if we're dealing with degrees that your calculator is in degree mode. Okay. But I listed off I needed to find angle A, side C. We have found angle A, side C. So my triangle is now solved. We can have some other problems that are more word problems. And so we want to draw the picture. And honestly, I think drawing the picture is the hardest part. That's not true for everybody. Some people really understand what these are saying and they can draw that picture. But for most people, understanding what this is saying and drawing it is really hard. And honestly, the best way to get better at that is to just practice them. So we're going to draw the picture, and I'm going to try and go slow so that you can follow along. But If you at all are still confused and you have more questions, come find me and we can talk through it some more together. But there's a lot going on in this problem, okay? We're going to read through it. Before I even start the picture, I want to read through this and figure out, try and get an idea in my head of what might be happening. So there is a pole, and it's tilting towards the sun at an angle of 8 degrees from the vertical. And it casts a 22-foot shadow. Okay? It says the angle of elevation from the tip of the shadow to the top of the pole is 43 feet. I want to know how tall the pole is. And I'm actually going to change that. I'm going to say, how long is the pole? I want to change it and adjust it so it's how long is pole, because I think that's going to be a little bit closer tied to what the rest of the questions in this set are looking at. But I want to draw this. So I'm going to get some colors here so it makes a little bit more sense. We're going to start by drawing where my sun is, because the way the pole is drawn is in relationship to where the sun is. It is tilting towards the sun. So I want to put the sun in there first. So I got my sun. It's happy. It's smiling. It's a sunny day. And I've got the ground. Nice green for the ground. Ground's going to be a horizontal line. I'm going to actually make that a little bit smaller so that I have some more room to work. But I've got a pole. And the pole is not quite vertical. So what I'm going to do is I'm going to dot in a vertical line to help me draw this. It's not quite vertical. It's leaning towards the sun, but not by much. Only at an 8-degree angle from vertical. So it looks like this. And that's actually even more so than it would be. But it's just a tiny, tiny angle. This angle in here, that's 8 degrees. That's it. So that's going to come into play in a minute. Okay? But it does. It casts a shadow. And the way shadows work is they're always, you know, from that direction of the sun coming down. So it would be coming down from upper left to bottom right. So my shadow is going to be down here. So here's my shadow. That's 22 feet. And I got a lot of stray marks here. I'm going to clean that up a little bit. It's 22 feet. And it says, okay, angle of elevation from the tip of the shadow, so from down here to the top of the pole. That's 43 degrees. So I'm going to draw that in there. I said my angle of elevation. So that's this angle here. That's 43 degrees. And I want to know how long the pole is. So that's going to be this length here. So they're asking us to find x. And we are almost done with our picture. We are so close. And I know I kind of went through that fast and I said I was going to go slow. And I went through that kind of fast. But we've got our pole. It is tilting from that vertical. So we want to tilt it a little bit closer to the sun. It says it tilts towards the sun. And I want to draw in my shadow. And my shadow is always going to be that that horizontal across the ground there. And then the orange line represents from the top of the pole to the end of the shadow. All right, and we filled in our 43 degrees. We filled in our 22. Now that 8-degree angle, that's not really an angle in my triangle. It's a part of one of the triangle angles, but it's not really a triangle angle. The triangle angle is this entire thing, which is more than 8. It's more than 90. If I just did the vertical here, that's the right angle. That's 90 degrees. I went an extra 8 degrees. So this angle in my triangle is 98, which is the angle I want to use. And that doesn't really look like an 8, so we'll try that again. 98 degrees inside my triangle. But now I can get started on my problem. I'm trying to solve for x. X is a side length. When if I'm going to use law of sines, I need to know the angle opposite x. I know that one. That's 43. So I can set up that pairing already. Somewhere in my problem, I'm going to use sine 43 over x. And what I want to do is I want to set this equal to another pairing. But my problem is my angle 98, I don't know the side across from it. I know the side of 22, but that's not across from my 98. I either need to find that orange length or I need to find the angle across from the 22. And one of those is definitely easier than the other. It's almost always easier to find an angle than it is to find a side length. So I know the 22. What I want to do is I want to find the angle across from 22. So we're going to use the fact that angles add up to 180. So I'm going to say, okay, I want to take my 98. I want to add 43. And then this is like my missing angle. And all together, these have to add up to 180. So I want to do some subtraction from 180. And we get that missing angle up at the top of the triangle is 98 minus 43, 39 degrees. So that's this angle here. This angle up at the top is 39 degrees. That pairs up with that 22. And now I have a law of sine set up. Sine of 43 degrees over x equals sine of 39 degrees over 22. And I want to solve for x. So again, it's a proportion. Cross multiply, best friend. We get x times sine of 39 equals 22 times sine of 43. And we're almost there. I need to get x alone, so we'll divide. So we get x equals 22 times sine of 43 divided by sine 39. Nothing cancels, so it goes into our calculator exactly as is. 22 sine 43 in degree mode divided by sine 39. And we get that x, or the length of the pole, is 23.84 feet. And that's our final answer. Okay, and I know it's feet because that 22, they told me, was in feet as well. So it's the same units there. Right. Definitely the hardest part is getting that picture drawn. But then you want to set up your law sign. So it's always angles pair with the sides opposite them. Okay. What we're going to do is we're going to find areas of these different triangles. And these are just formulas based off of the typical area formula for a triangle. This just sort of saves a little bit of work in finding the heights of those triangles. The way it's currently written, I'm not a big fan of because it's not clear where the input to sine ends. It is in there that it's the angle is the capital letter there, but I would really prefer it if this was written as 1/2 sine with parentheses a times BC. Okay, and this we're not going to deal with quite so much. If this is something that I'm going to ask you to use on a quiz or on a test, I would give you this. This is more something that you might see in your homework. So you want to make sure you have this handy in your notes when you're talking about homework. But on a quiz or a test, we're not going to use this quite so much. So we are going to go and we're going to find the area of that oblique triangle from problem 1. And so for that one, we had that information. And I can pick any of these. It doesn't really matter. But I do need to know two sides. And so if I remember correctly, we started off by knowing that side B was 28. Okay. And then we figured out that side C was 54.49. I never asked them to find the area. so I got 40 degrees. All right, so web assign. Try your very hardest not to round until the very end. And then application problems, you want to do these on another sheet of paper. You want to draw the picture. It is so hard to do these problems if you don't draw the picture. So you want to draw the picture, fill it out. If you're asked to solve a triangle, I definitely recommend making a list of the triangle sides and the angles that you need to find so that you can keep track of it. And then you can check things off as you go along. If you have any questions at all, please do not hesitate to let me know. Have a great day.